Hello friends, the topic of today's discussion is hydrostatic forces on vertical plane surface submerged liquid. When we speak of hydrostatic forces, that means the fluid is at rest and the velocity of fluid is zero. Hence we can say the velocity gradient du by dy is equal to 0. As velocity gradient is 0, hence the terms mu du by dy, which is equal to shear stress, is also 0. As there is no shear stress in the fluid, that means we will be considering only two forces. One is pressure force and second is self weight. The prerequisite for this particular derivation is understanding of total pressure and center of pressure. Total pressure is defined as the force exerted by static fluid on the surface when the fluid comes in contact with the surface. This force is always at right angles, or we can say the force at normal to the surface in contact. And center of pressure is defined as the point of application of total pressure on the surface. These are just definitions. Let us go to the concept and see what we understand from the diagram. To understand the concept of total pressure and center of pressure, consider this diagram. Now, as per the definition of total pressure, it is the force exerted by static fluid on the surface in contact. See, here we can see the pressure is acting perpendicular to the surface in contact on both the sides, as well as this pressure will be acting perpendicular to the base also. So whenever fluid comes in contact with the surface, it will always act perpendicular to the surface. But what is total pressure? It is not this pressure, it is not this pressure, it is not this pressure, but it is resultant of all these forces. So here we can write, say this is the resultant of the forces acting on this particular wall, and here we have resultant of forces acting on this particular wall. Now you can see, if we consider the center of gravity of this particular figure, it will be somewhere here at the center, right? But the pressure is acting at this particular point. Now why it is so? Because we have studied in hydrostatic law, the pressure will go on increasing from free surface of water till the base of the water. So you can see the pressure is varying from this particular point, that is free surface of water, till the bottom of the surface. As the distribution of pressure is not same throughout, hence the pressure is increasing, and hence the total pressure is not acting on the CG of the body but somewhere below the CG of the body, and this point of application of total pressure is known as center of pressure. I hope the concept of total pressure and center of pressure is clear to you. Now let us move to the derivation part. Consider a plane vertical surface, say surface AB, which is vertically immersed in a liquid and having some arbitrary shape. Let A be the total area of surface. So this particular surface will have total area A. Let H bar be the distance of CG from free surface of water. Let H star be the distance of center of pressure from free surface of water. We will start our derivation with the first part, that is total pressure. To begin with derivation, we will consider a small elemental strip on this arbitrary area. The area of this elemental strip is dA. Intensity of pressure on this small elemental area is given as P is equal to rho g h. Now the total pressure force on this elemental area is given as dF, which is equal to pressure intensity into area, that is rho GH into dA. But we are not interested to find out pressure force acting on this small elemental area. We want pressure force acting on whole area. For that we will integrate this equation, integrating on both the sides. So we'll get total pressure force acting on this is, as rho g is constant, rho g will remain outside of integration. We'll get H into dA. So integrating into HdA, we get F is equal to rho g. dA is for small elemental area. If we integrate over the entire area, dA will become A, that is area of entire surface, and H will become H bar, that is CG of entire surface. Now let us go to second part of our derivation, that is calculation of center of pressure, which is given by H star. As we can see in this figure, the center of pressure is located at distance H star from free water surface or free liquid surface. The calculation of center of pressure is based on principle of moments, which states that the moment of resultant force about an axis is equal to the sum of moment of the component about the same axis. Here the resultant force is acting at point P, and small forces are acting on small elemental area dF. So let us first consider the moment of resultant force about the free surface of the liquid. So it will be F into H star. Let us name this as equation A. Now let us consider moment of all small forces dF about the free surface of liquid. So it will be dF into its distance from free surface, which is equal to H. But we already know what is dF. dF from this equation is rho GH into dA into this H. So the equation becomes rho G H square dA Now the sum of moment of all these small forces will be integration of this equation, because we have considered earlier that this figure is made up of all small elemental strips like this. So sum of this all small elemental strip would be integration of this equation. As rho g is constant, we will keep rho g outside of integration. We get here is h square into dA. Now see here, h into dA is moment of this particular small elemental area about the free surface of liquid, and h square dA is second moment of area about the free surface of liquid. Hence second moment of area is nothing but moment of inertia. So I can write this equation as rho g I0, where I0 is moment of inertia of the small elemental strip about the free surface of the liquid, and hence sum of moments about the free surface is equal to Ig is equal to rho g I 0. We'll name this as equation B. Now we have equation A here and equation B here. Now as per principle of moments, we will equate the moment of resultant about the free surface and sum of all small moments about the free surface. So we get here is F into H star is equal to rho g I 0. But we know F is rho g AH bar, so we will substitute it here. Into H star is equal to rho g I 0. We can cancel out rho g from both the sides. So we get here is AH bar into H star is equal to I0. But from the parallel axis theorem, we get I0 is equal to Ig plus AH bar, where Ig is moment of inertia of area about an axis passing through CG of the area and parallel to the free surface of the liquid. So we will write AH bar into H star is equal to Ig plus AH bar square. So we get H star is equal to Ig upon AH bar plus AH bar square upon AH bar. So we get H star is equal to Ig upon AH bar plus H bar, which is the required expression for location of center of pressure for a vertical plane surface submerged in liquid.